In this question, we're asked to determine whether the atom underlined in red in each case is oxidized or reduced, or neither oxidized nor reduced, in each of the cases. So in order to do that, we need to find the oxidation state of, in this case, hydrogen on the reactant side and on the product side. So on the reactant side, hydrogen's in a compound, and hydrogen is almost always +1 in compounds, and on the on the reactant side is +1. On the product side, hydrogen here is elemental. It's by itself. Elements have oxidation states of 0. So the oxidation state of hydrogen went from +1 to 0. Now we have to determine, is that oxidation, reduction, or neither oxidation nor reduced? Clearly it's oxidized or reduced because there is a change. This would only be the case if the oxidation state were the same on both sides. There are two mnemonic devices that may help you with this. One is oil rig. That means oxidation is losing, reduction is gaining. And what they're talking about losing and gaining is electrons. So oxidation is losing electrons, reduction is gaining electrons. Another one is Leo the Lion says grr. Losing electrons oxidation, gaining electrons reduction. So these are two different mnemonic devices you can use to help you remember this. So in this case, we go from +1 to 0. Since electrons are negatively charged, this is gaining an electron. Reduction is gaining, or gaining electrons, reduction. So this is reduced. Next, we have Cl-. So this is a monoatomic ion. So this is oxidation state is -1. Here we have Cl2, which is elemental. So this is 0. So now we have from -1 oxidation state to 0. This is losing an electron because electrons are negatively charged. This became more positive, if you will, or less negative. It went from -1 to 0. So that's oxidation is losing electrons, or losing electrons oxidation. So we have oxidized here. In this case, we have sulfur, and we don't really know the oxidation state on sulfur here, but we do know that on this side it's 0 because it's elemental, it's by itself, it's not with any other compound. So we need to figure out the oxidation state on sulfur over here. Well, we know that hydrogen is +1, so 2 times +1 plus sulfur equals 0, because this is an overall 0 charge. So 2 plus S equals 0, S equals -2. So the original oxidation state on sulfur in the reactant side is -2. It went from -2 to 0. Since electrons are negatively charged, this is losing electrons. So this is oxidation. Oxidation is losing electrons, oxidation. Either way you want to use it, this is oxidation. In the last case, we need to figure out the oxidation state on carbon on the reactant side and again on the product side. So here we have a monoatomic ion, sodium. So 2 times +1, because the charge on sodium and its oxidation state is +1, plus carbon, plus 3 times -2. 3 times the oxidation state on oxygen, which is -2, equals 0, the overall charge on the species. So here we have 2 plus C minus 6 equals 0. C minus 4, 2 minus 6 is -4, equals 0. C equals +4. So on this side, the oxidation state on carbon is +4. It's a little hard to see there, but that's a +4. And what about in carbon dioxide? I did this one on a previous video, but we'll do it one more time. Here we have carbon plus 2 times -2. 2 times the oxidation state on oxygen equals 0. So here the overall charge is 0, so it equals 0. Carbon -4. 2 times -2 is -4, equals 0. Carbon equals +4. So here, carbon equals plus 4 as we solve this out. So on the product side, carbon is again plus 4. So plus 4 to plus 4 is not a change. So this is not an oxidation reduction reaction, at least with respect to carbon.